think we can start now. So today we are going to start with the course PDE, and since we have gone through some of the fundamentals already, we are going to use few minutes to summarize everything there. Or I'll be taking my time to dig on some things. Yes, sir. I'll be taking my time to dig on some things. Then we move on to the first order of video, because the next video of with Dr. Ali, I know Dr. Ali will be coming with first order video. Okay. So now I think that from watching the video, you have seen that everything in PDE is like ODE. You see, everything in PDE is like ODE. So please, what then is ODE? So that we can link up to the PDE and move on. If somebody can help us with the definition of ODE or what ODE is about.
ODE is with only one independent variable. Whereas PDE is with several independent variables.
Alright, so we are saying that ODE contains or deals with what? Only one independent what? Variable. Let's say X. So if we have a function y, then the y will represent the dependent variable. Then the x will represent the independent variable. But in PDE, we are saying that it contains several independent what? Variables. That is two or more independent what? Variables. So with that one we can get, and now please, the independent variable is no more y again. Take note. Is the u. The u is an independent variable. But some books even dependent variable. Even some books don't consider to be make it u. They sometimes they use this. Say 5. Then so depending on how it is, but based on our content, we normally use the u for our dependent variables. So we are saying that the PDE can be in terms of x. We can have the x be the independent variable, y, and the rest z. But there is something that we have to take note about. That in PDE, let's go straight to the point. So what then is PDE? In PDE, what? It is a differential equation. You can write. It is a differential equation that contains partial derivatives. For instance, in ODE, you have let's say y dx will be equal to 2x equals to 3. Then we say that this is what? An ODE because it's having a derivative in it. It doesn't matter whether the first order, the second order, or whatever order. Once it's having a derivative in it, you can say that it is what? ODE. I hope it's clear. Very good. But in PDE, what? It is a differential equation that contains partial derivative. For instance, we can get plus 1 over, let's say, v to be equal to 0. Since we are having a partial derivative in it, then we can say that it is a partial what? Differential equation or a PDE. Now, what then happened in ODE and what then happened in PDE? Now, in ODE, we have only one independent variable and one dependent what? Variable. But in ODE, since we have only one independent variable, let's say to differentiate 2x plus 1, what are we going to get? dy dx will be equal to 2. 2. Then what about this? Down what? 0. Alright. Let's say we have to integrate 2x plus 1 dx. What are we going to get? 2 over 3 x squared. It's going to be x squared. X squared r plus x. Then plus c. That is only one independent variable. But in PDE, when we are saying that the function is in terms of x and y, please let's work this one again. Let's assume this example for that. What is happening here is that in PDE, the dependent variable in the equation depends on the more than one independent variable. And what happens is that when you write the partial derivative of the y, the x, what it means is that there is a change in y when x changes. What we mean is that there is a change in y when x changes. And here I can specify it for instance with this. I can add another one. Let's say 2. So that you can say that there is a change in y when x changes and t is what? A constant. What we are saying is that here we can say that if we are taking the partial derivative as respect to x, that means that the x increases while the y and t remain what? Constant. So as x increase, the y and the t will remain what? Constant. That is when you are taking the partial derivative as respect to x. If you are taking the partial derivative as respect to y, it means that the y will what? Increase, while the x and the t will remain what? Constant. So it's not like in PDE, in ODE. Since we have only one independent variable, the constant we only use c. So let's assume we want to integrate this. Let's assume we want to integrate this as respect to x. So what are we going to get? Let me do it. Okay, between
Let's keep.
okay, let's keep. Then plus 2x. Plus c. But here it will be c. We are not dealing with single calculus. Single calculus is the same as ODE. We are dealing with several variables. So we are saying that here, since we are taking the integration as respect to x, that means that x will increase while the y and t will remain what? Constant. So the constant that you are telling me to do c is a function. It's what? A function. So we can't just use c, but you can use it as a g in terms of y and what? T. That is the constant. Because we are integrating as respect to x, while y and t is remaining constant. These are always like. And if it's without this t, it will be like this, depending on how it is. So let's take note of this one. It's very important. How is like. Very good. So we are not dealing with single calculus here, we are dealing with several calculus or whatever. So let's now quickly move to the notation in PDEs. The notation in PDEs. For instance, the y, the x. This means u subscript x. So anytime you see u subscript x, it means that the u is the dependent variable and the x is the independent variable. That means that we are taking the partial derivative of u as respect to x. I hope it's clear. Very good.
Is it the u on
Yeah.
with the u?
Sorry. the u over the x. Alright, so it means we are taking the partial derivative of u as respect to x. If you make here y, then you have to also make here y. Y is as with x. Yeah. Thank you. Okay, what about next? You move on with that. Just like writing this y. The u, the y. What does it also mean? Use that phrase. Why? Very good.
Pretty wide again.
I like writing why. What does it mean? Yeah, this means that we are taking the partial derivative of u as respect to x twice. So it's u subscript x. Okay, we move on. The same way we can relate it to this. Okay, what will be this? What will be the left hand side for this? Why do you like writing y like that?
The square u, not the square u.
The square u. The square u and the y square. Alright, so give me the left hand side for this. The
U over
the u over the s
The y.
the y. So this means that we are taking the partial derivative of u as respect to x. After you are done, then you go for the same result as respect to y. And when you are taking the partial derivative as respect to x, that means that you are treating y as constant. And after getting the results, you move again by treating x as what? Constant. So that's how we do it. Very good. In case you don't understand it, you can come to us today. See how to help you. Alright. What about this one too?
UXX1.
So yeah, we are taking partial derivative as respect to x how many times? 2 times. Then then what? Alright. You can write the left hand side for this. You can write the left hand side for this. You can also write the left hand side for this. That's taking the partial derivative as of u as respect to x 3 times. Same thing, 3 times. That's what that means. Okay. Which one? This one. Yeah, is this one of second derivative? We are taking the partial derivative 2 times. So it will be second derivative. So yes, you're supposed to be forward. Very good. Alright. And the same thing, I think this place is clear because here is so when you're doing this one, be careful with it. Please, I hope you understand the question. Alright, so that's why it's like that. So this one will be partial derivative of u as respect to y 3 times. So you can even do it like this. You can even do it like this. Alright, let's quickly move on to the order of derivative. For instance, we are saying that u subscript s y, meaning the partial derivative of x, then the result we get, we take the partial derivative of it as respect to y. We are going to see, it is the same as taking the partial derivative of y first before you take the x. It's the same thing. Think without trying with the question. You can't say whether it's theory or what. No. So let's use one question. Alright. So let's say we have a function, the dependent variable is what? Sorry, you always don't forget in terms of x, y, and z. Let me emphasize on this. Even if you don't see the function that is going to give you in terms of z, it doesn't mean that you won't treat z as constant. It's still a constant. Obviously, it's still a constant. Okay. Let's consider x power 3, y power 2, and z. So let's find the partial derivative. Let's find the partial derivative of x, y, z to see if it's going to be the same as, or let's try it. Only, okay, I can bring this and ignore this. Let's try with only this. We are going to take the partial derivative of x and y to see if it's going to be the same as. Oh. So this one means that we need the partial derivative as respect to x first before the y. So what the partial, we know that the u is equal to it's still the same thing. So what will be partial derivative of x? So you take the derivative as respect to x while treating y as what? Constant. So you can even close it like this. When you take the derivative of x squared, you want to get 3x squared. Then you bring the constant, that's all. So 3x squared y squared. Then move to the next, that is partial derivative of x, y. That is the first, going for the second. That one will be treated x as what? Constant. So you close everything here. Take the partial derivative or take the derivative of y. What do you mean? 2x. Sorry, 2y. Now the 2 multiply the constant 3 here, even though the whole thing is constant. So 2 multiply this, you get what? 6. But 6 is already there, then this should be what? Now let's check this. Okay, let's leave that one and go for this. So this one means that we take the x first, the results we get, we go for the y. Now we are moving on to this. Which one is coming first? Y. Before we go for the x, let's go for it. Because that is right now. You have the answer, you can give it out. Please take 3 6 x squared. Please, is it the same as 6y x squared? Is it the same thing? Is it the same thing? Because multiplication is complicated. Alright. Very good. So can you say that this is the same as this? Yes. That means that in PDE, the order doesn't matter. The order doesn't matter. Whether you take this one first or whatever, it doesn't matter. Yeah, it's always. Oh.
S2 plus y.
Okay, let's try that example. S3 plus y squared. Alright, so let's try as respect to x, y, and minus. Okay. Then let's go for this and see whether it's going to question for all. So partial derivative
respect to x.
As respect to x. But we are treating y as what? Constant. Anytime you differentiate constant, what is that? 0. So, as respect to x, what will you get? Then we leave the rest. Oh. But that one only is who subscript x. X. So we now go for use subscript x, y. So the same thing. We are taking as respect to what? Here is as respect to x. We are done with it. That's why this is 0. So now we are taking this result as respect to y by treating x as what? Constant. So the whole thing will be 0. So this one remains 0. Okay. This one means that we are taking the derivative of this as respect to x. We want to see whether this will be the same as, I think it's a nice question. We are going to see if this is going to be the same as this. So before you can get u subscript s y, you need to go for u subscript x. By treating y as constant, so this goes 0. Then this will be 3s squared. After we done, then we take the same result. Take it as respect to y. By treating x as constant, then the whole of this is x. So we get 0. Please help me select. We are going to get 0. Alright. So this is a big 0.
Yes.
Which one?
The constant here and the constant here.
This one.
Yes.
You see, you mean the opposite?
This one.
Yeah, because of the black. The black is splitting it. Okay, somebody wants to.
It's just like the wider is just like having one, like a constant value of
A
one.
constant.
Because of the black, so the wider is now one, like 1 or 2. That's how you
See, anytime you are treating something as a constant, you pick it as any value. You pick it as any value. Alright, you pick it as any value. In case somebody also have another.
But let me ask you.
Okay, stick it.
Now with this differential, it's like the normal derivatives that we do. But here, we want to check the order as to when we turn xy or yx, is it going to be the same or not the same? But you know, we shouldn't forget with our product rule that when a constant multiplies, for example, right, maybe 3x.
Okay,
3x squared. Good. Here, when you have to differentiate this one, the constant 3 will be there. So the constant 3 will come. Then you differentiate the x to get what? 2x. So you write 3 times 2x. You see, the constants are still there. So here, when you have to differentiate x, y, and it's a product rule, considering the y to be a constant, okay, then you only differentiate the x, and the y will still be there as we are having the 3. Are you getting it now? But in a case whereby we have an addition, which is splitting them, the constant side will be what? 0. So automatically it will be left with what? Only the x part. And when you have to differentiate the product rule, that is the new xy. Because we don't have the y attached to the x. You see here, that part will be what? Will be 0. Is it okay then?
Pastor, your question is Alright, so now I hope you have you all agree now that as respect to x, we get this, and as respect to y, we treat x as constant. One is a constant, no matter how it is. Alright. Now we move on to as respect to y. So we treat x as constant. So this will be 0, and this will be 1. Then we move on again as respect to x by treating this as constant. Nothing is there. Even if this is there, what is that? It will be 1. So
Zero.
No the difference, like what our brother was saying, no the difference between the space and the dimension. Alright, so this will be, so the other still holding it. That no matter how you do it, it will still be there.
When X is there,
There is no one.
it's not one.
Two y. So like it's similar to what we do here. Alright. Yeah, it's a very nice question. It's a very nice question. Thank you for that question. Okay, so now that the order is clear, let's move on to the classification of order, first order PDE. Now that the order is clear, we can move on to the
So, to conclude, no, now we are saying that we use as quick as y is equal to 1, use as quick ys.
yeah.
So if the order is 3, 2,
It will still go.
when you
Like,
use
let's say u x y z be the same as even y x z will still be the same. Like, yeah, we don't want to do something more.
You cannot say PDE is communicating and associating.
Sure. We can say that. Yeah, you can say that. Like, but I say it's not a problem. Alright. Please, how many classification of ODE do we have? 3. One is and then
Linearity, order, and then homogeneity.
Homogenite.
so it's still the same thing as PDE. It's still the same thing as PDE. Please, when do we say that we have a homogeneous? Okay, so when the whole thing is equal to 0. For instance, dy when dy dx plus 2y equal to 0. Since this is equal to 0, everything is equal to 0, it means that it is what? A homogeneous ODE. But let's say if we have something like 2x, there is a name given to this. What is that? The forcing term. It's the same thing in PDE also. When I apply like this, we have a forcing term there. And this forcing term, if that is equal to 0, then we get what? A homogeneous. So I think this one is like still the same thing. Okay. So here we have a homogeneous and non-homogeneous. So we can get a non-homogeneous example like here we are dealing with partial derivative. So example of homogeneous, we can get partial derivative as respect to s, as respect to y equal to 0. We can also, in fact, we can write as many as we can. This is the first order. We can consider this. Alright. And for a homogeneous PDE, you can ignore the 0 here and bring any function there. It makes it what? Non-homogeneous. If this is not homogeneous because it's equating to 0, then the non-homogeneous will be like u subscript s, even though u subscript x plus u subscript y equals to 2x. This is non-homogeneous. That's all. Alright. Let's really come to the question.
Doesn't matter. Actually, the 2 u and x multiply the u.
We are talking of homogeneity and not about the y being the function.
No, I'm looking at the constant multiplying the u.
The constant multiplying. Like this. Okay. Alright. So let's go to order of PDEs. Order of PDEs. Now, in case you want to write something, you can write that the order of PDE is defined to be the order of the highest derivative in the equation. The same like. I should go back. You want to chip this? Okay, yeah.
So the first one is the first one. That's ux plus uy. You said it was it's supposed to say.
Yeah.
You said it was homogeneous, right?
Yeah.
So suppose the uy was at the other side.
This one was.
Yes.
You mean something like this?
Yes. So can you say in the or this is not homogeneous now?
Okay. A question to all of us.
I think that is a derivative.
No.
Please, a question to all of us.
Well,
Let me tell you. You see, for the function to be non
you are not doing right.
unless you have
No
a
problem.
percent term.
Let's hear you.
But for this one,
People are lost.
You are all interested.
unless you have a forcing term. The forcing term is the one that makes the function non-homogeneous. Okay, so if you have a forcing term like put in any example with a forcing term, unless like the one over there, 2ux and then plus uy, which is equal to 2x. See the 2x over there is, you can see that it's different from the function.
It's not derivative.
It's not a derivative.
Yes. Most of the time, the first term is not a derivative.
Yeah, it is a function.
Yes, sir.
That is the of whether f, y, is a function.
Every differential equation has parts. So where the derivative we classify it as the principal parts. Okay. So always you have to make sure that the principal parts are moved at one side. So if you have the principal part being moved at one side, then it becomes homogeneous. So
You will not. So if you look at that part and there's nothing again,
yes,
there's no process.
it becomes homogeneous.
We have some questions here that
So,
are
remember what Minter is saying. Let's use the example on the board.
Example.
Yes, you don't have to y to the other side.
So it becomes
Because it's a derivative.
Okay, somebody says that should write a question of what class
Example.
Example.
Yes.
U
U sub x is
sub s
plus
plus
u sub xy
u sub sy
minus uy.
minus uy
U
sub y
is plus sin x.
sine
And if you want to say
of u. Alright. So
this one is homogeneous or not?
he asked whether it's homogeneous or not.
It's not homogeneous.
Because of sin x.
Can you write the send the science?
We can send that one to the side.
It cannot be question.
No, it's not like it's equating to the that's the forcing term can be the forcing term can be a dependent variable. The forcing term can be, it's always a function. Okay, so for instance, okay, if this one
So if you was assigned to sin x, what happens?
that's what I want to bring right now. That's what I intend to bring right now. Like this.
it's still homogeneous because the u is not derivative. Yeah.
It's still homogeneous. It's not homogeneous.
It can be a function.
It's not homogeneous.
However, the U is behind, it's multiply the sign. If the U is multiply the sign, you have an argument.
Where the u is multiplied by.
If U sin x, not going to go.
So I think we are concluding on it that it's supposed to be in terms of the independent and the dependent, but not the partial derivatives. How is it? Not the partial derivatives. I think that one is correct. Alright. That one is not. Then you know already. You said I'll write for you. I think it's part of the tutorial. I'll write some more for us to discuss. But I want us to finish the order, then we consider the whole thing. So you don't worry. We will come back to it. Okay. So, like in OD, I always want to relate because in OD, when we say order, it means the one with the highest what derivative. So in the same way, here too, if you are talking about order, we are talking about the one with the higher partial derivative. Okay. So use of x plus 2x is equal to 0. What will be the order of this?
First order.
What will be the order of this? First order. Why is it first order? Say.
Because the derivative is just first derivative.
Second order. Please have this clear. Alright, so we can cite as many examples. Let's say this is a function. Okay. Please, what will be the order of this?
Second order.
Why is second order? Can we say that here is a partial derivative as respect to t twice? Here, partial derivative as respect to x twice, so we combine 4 order of 4. Alright. What is the name given to this? Degree. Very good. So that one is not about order, it's a degree. Even if it's a transcendental function, for instance, e raised to 1x or 4 or sine or it's still a degree. Okay. Then, I think that one will. Okay, so let's classify the following according to their homogeneity and order. When we talk about homogeneity, it means that they can be whether non or what homogeneous. So let's classify this together. The first one is how to normally do it, they start together. So let's discuss this. It's multiply. Okay. Okay, let's first talk about the orders. First one, the order. First order. Doesn't matter with the dependent variable multiplying. Is that the focus? Alright, so we can move on. Or any chipping. Okay, so it's first order. Second question. The order.
First order.
First order. Is it the focus? So first order is. What about the third one? Fourth order. Okay. What about the fourth one?
The fourth one is I.
I think that's what I saw for the tutorial. The PDF. It was I. Alright. The order. Second order. The fifth one.
First order.
In the square root, they focus that if you square root on that one, you get on that 1.5. Alright, so the others are clear. Let's go to whether homogeneous or not homogeneous. Question one, let's discuss. Not. Who else? Not. Please, you agree that it's not. Okay, so not homogeneous. The second one.
Homogeneous.
Not.
Homogeneous.
Okay, if you are saying not, why? If you are saying homo, why? Okay, because somebody said because of next. So you are saying because of the X2 is not. Where are they? No,
Why the X?
Let's use the first.
There's no percentage.
okay, so we have to know what this was.
Yes.
Okay, so I think we can shamble it this way. The forcing term can be in terms of the dependent variable. The forcing term can be in terms of the dependent variable. If the forcing term is supposed to be in terms of the independent variable. For instance, x, t, or x, y. Or, now with this, you can see that it is x and the u. This is how it's clear. So the forcing term, it can be in terms of the, if it is only this.
Then
You can send this to this side for it to be what? Non-homogeneous. Okay, then if I put it for me, let me check if I have it here. Okay, I have it here. Let me try this. So that we discuss on it. Where is it? Okay, we are saying that partial derivative can be in terms of this. So that's the general one. And this okay, well, the whole thing would be what? The homogeneous, non-homogeneous. But it's the forcing term is zero. And this is the forcing term. And the forcing term is the term of. Please, let's first look at the left hand side. The left hand side means that this is a partial differential equation. And it's in terms of the independent variable x. The independent variable y. And this is the y. The dependent variable. The f and the u, which one is the dependent variable?
Is the U.
The u. Okay, so don't let that one. Okay, so the u is the dependent variable. Alright, so this is just the u. And that's what the focus here. The focus here is this. And we can see such in the forcing term. We can see that it is in terms of u here. So the forcing term will exclude this because this is in terms of the dependent what? Variable. So it failed to be a forcing term.
So in the nutshell, that the forcing term should contain a dependent variable.
Yeah. Simple. So, first order, then, sorry, homogeneous, this is what? Non-homogeneous should be what? The homogeneous. So always for the homogeneous, we have to see the independent variable x, y, the dependent, and the partial derivative. No matter what it's going to be as respect to. These are always clear. And the forcing term is always. So even if you have this to be on this, even if you have a forcing term to be here, you can send it here. But with this, you can't send it one here because it's in terms of the dependent one. Because I hope this is clear.
So the general
Yes.
Yeah, so the general form for the homogeneous is when you
All those things equal 0.
this is because of the zero, this is because of the zero. So the focus is what is in terms of. That's why I think Madam 22, Madam 1, I didn't know internship now. She's back. Alright. So that is that. Hey, the third one. Now the concept is there, so you can move on. The third one. Homo or not homo? Homo. You see that? Very good. This is not the focus. What about this?
Homo.
Are you over? You over X?
Are you ready? The third one.
Yes.
Okay.
One there.
If there is a square.